Math machines, connecting math, science, and technology. The LACI SmartCart is a serious tool for integrating math, especially algebra, throughout STEM. It can be used in all areas of STEM and at all levels of mathematics, from pre-algebra to introductory calculus. It allows for a wide variety of authentic learning tasks that are brief, career-related, engaging, and mathematically challenging. We're going to show you here two examples of how it's used. The first one is at a relatively low level of math, dealing with rates, ratios, velocity, and signed numbers. The task is to control motion using really only the idea of velocity, distance, and time, and how they're connected. We begin by giving the students a broken CNC computer program that is intended to pick up the block and drop it into the container at the end, but which doesn't work. The authentic task that the students have is very simply to correct the program to make it actually pick up the block and drop it into the container, and once they've succeeded, to change the program even more so that it works more efficiently. The control program has several different steps in it that essentially are all about the time of each segment of the motion and the velocity at which it moves. The students have freedom to change the velocity and to change the times. It's certainly possible to solve the problem using the computer controls for LACI, but it's also possible to do the whole activity with a graphing calculator and an interface like the Lab Pro or the CBL2. Here we show a successful solution getting the object in the container using a graphing calculator. Another use for LACI that's more explicitly algebraic builds on the very popular and very effective graph match activities. Many math and science teachers have students move in front of a motion detector to gain a conceptual understanding of motion, but the advantage of using LACI is that it can make an extra link to actual kinematic equations or to quadratic or linear functions by having the students use actual algebraic functions to match a particular graph. We have a different software package here to control LACI in this way, and the essence of it is essentially an empty box in which students can write virtually any algebraic function that could be described in Excel or other systems. Here we have LACI attempting to match a 5-segment graph that includes a period of uniform acceleration, uniform velocity, uniform negative acceleration, another uniform velocity, and then a positive acceleration to bring it back to 0. And looks like LACI is doing a fairly good job of matching both the position graph and the velocity graph. Must be that somebody got the functions right that they put in the control system for LACI. Quadratic functions and accelerated motion are certainly very important for a great many students, but the software goes well beyond that. Essentially, any function that can be described algebraically can be included as a part of the software, and it can either be x as a function of time, or it can be the velocity as a function of time.